Hello, everyone, and welcome to our IVD Ready webinar. So our webinar today is dedicated to a very important milestone of the IVD Ready program, which is a gate opening, and we are very excited to welcome you at this webinar. My name is Elena Gromberg. I am head of a customer success team by Platomics, and I'm happy to guide you through the agenda of our webinar today. But before I move to the agenda, I actually want to welcome a new attendees of the IVD Ready program, since our community is growing very rapidly, and I will just briefly tell you what this program is about. IVD Ready program is a one-year free program that we started in May this year and that aims to support laboratories. IVD Ready is a gateway to IVDR compliance for all European laboratories by May 2024. And it consists of two main elements, one of which is a series of webinars, like one we have today. These are educational webinars that help you to understand IVDR requirements better and guide you through the creation of the documentation for IVDR compliance of in-house tests. We already recorded 5 previous webinars, and you can find these recordings on our YouTube channel and catch up with the rest members of our community. The second element of the IVD Ready program is our compliance platform, Plato X IVD Assistant. This platform is absolutely for free for all European laboratories, and you can request an access to this platform by using the link in the chat or using the information on the slide. If you already requested the access, then you will receive your personal user credentials within 5 business days, and you will be able to start using our platform. I also want to make one additional announcement about an article on the online news portal Genome Web, which is giving more information about IVDR, about the new regulation, and is also featuring Platomics and IVD Assistant. We are happy to provide you a free access to read this article until December 21st. You can access it using the link that we send now in the chat, or by scanning the QR code that you see on our slide. Okay, with this, I want to move to the agenda of our webinar. And as you all know, today is a big day for Platomics. We open the gates, which means that we connect laboratories and manufacturers through the Workflow Studio. And we are happy to introduce the Workflow Studio to you today. Since we always value the feedback of our members of the community, we as tradition want to start with poll and ask 2 questions. Then we will proceed with the invited speaker. Today we invited Dr. Hübschmann, who will talk about a specific use case of a workflow with the zoom in on one step of a workflow, which is a bioinformatic analysis, and he will show how high the complexity of this step is. Then I will announce the results of the poll, and we will finish the webinar with the demo session, as always presented by our head of the regulatory department, Andreas Oberleitner. He will present the Workflow Studio and explain how it works. And then I will tell you what we will do next in the next webinar. So right now you will see on your screens a poll with 2 questions. We would like to ask you, first question, regardless of which tool you are using, what percentage of your lab's in-house tests have you started documenting thus far? And here you can select just a single choice. And the second question is, what are the main blockers in making progress with documenting your in-house tests? And here you can select a multiple choice of answers. We thank you in advance for your feedback. And now I would like to give over the word to our invited speaker.
Elena, thanks a lot for the kind introduction, and thanks a lot to Platomics for this great opportunity to speak here. And I will sort of do this very much focused on content and on the procedures. And this is a use case about a sequencing laboratory for precision medicine, and in particular precision oncology, at an academic institution. My name is Daniel Hübschmann. My background is in physics, mathematics, and medicine. I have gained my clinical experience in pediatric oncology. And since 10 years, I've been working in bioinformatics, and I am very lucky to lead 2 research groups at the German Cancer Research Center, where we are actually responsible for translational parts of precision oncology programs, where actual patients get enrolled in a fast-track sequencing program, and targetable variants are identified, and treatment recommendations, evidence-based individual treatment recommendations are being made based on these targetable lesions. So now I would like to introduce this talk by mentioning 2 regulatory contexts in which we operate as a laboratory. One is the IVDR, and the other one is the ISO 15189. And actually, both will play a role in my presentation. So I would like to introduce a process chain which starts with pre-analytics. So for example, sample preparation, extraction of nucleic acid. It then goes to sequencing. In our case, this is short read next generation sequencing, but could also be long read sequencing, or whichever technology laboratories may use. And then there's bioinformatics, and then there is the part which is highlighted in yellow here, which is a very important part by the clinicians to select the variants which may have been pre-selected by bioinformaticians, to attribute world knowledge to that, and based on world knowledge to make a match between the patient and the drug which is to be recommended, or between the patient and the clinical trial into which maybe the patient can be included. And so the result of the selection procedure goes into a report, which we call Report 1. Report 1 is what enters into the Molecular Tumor Board, which is an interdisciplinary platform to discuss the individual cases. And then the output of the Molecular Tumor Board, which actually then contains the treatment recommendations, goes into a second report, Report 2, which can then be sent back to the primary caregiver or to the patient himself. And here bioinformatics is very big. This is not because I consider it to be more important than the rest. It's just my area of expertise, and I want to zoom a little bit deeper into it and to stratify it into, on one hand, a first part which can be fully automated, and a second part which can only be semi-automated. And here are a few examples of things that can happen in either of these 2 parts of the bioinformatics workup for individual cases in a precision medicine laboratory. So fully automated bioinformatics would contain alignment, quality control, variant calling, technical annotation and filtering, or if you have RNA sequencing in your workflow, you may be interested, for example, in transcript abundance or gene expression. And the second part is about medical annotation and filtering, as opposed to the technical annotation in the first part, identification of targetable lesions, or also data integration. So when we go back to this whole process chain, underneath, you can see here the Tetris of the different units as we have organized it in the German Cancer Research Center. And this is by no means like the names themselves are generalizable, but I would still assume that a complex process chain like this in every laboratory probably involves different units. And so SPL is the sample preparation lab, NGS core facility. This is Omics IT and Data Management Core Facility in our setting. This is Bioinformatics and Precision Medicine. This is the area which I myself supervise. This is Translational Medical Oncology. So yellow is the part of the medical doctors. And Pseudo is a secondary use of data in oncology. Those are colleagues who develop a visualization and decision support system, which also is involved in this whole process chain. So when I now focus on this part of bioinformatics for precision medicine, I can tell you that we operate a set of workflows, and in the oncology setting, we have tumor and matched control in order to make the distinction between somatic and germline variants. What comes from the sequencing machine is a file of format FASTQ. It has to be aligned with algorithms based on the Burrows-Wheeler transform. This yields a BAM file, and based on the combination of tumor and matched control BAM files in the oncology setting, we can run a series of variant calling workflows. And actually, it's one workflow per variant type. So one for SNVs, one for indels, one for structural variants, and one for copy number aberrations. And the results are then lists of variant for both somatic variant calls and germline variant calls, and additional outputs, like, for example, from CNV calling a fit of the optimal purity ploidy. We also have a set of workflows for RNA-seq, so we want to determine gene expression and also identify fusion genes. And we want to integrate all of this into summarized results. And all of this happens in our setting in a workflow management system, which is called OTP, the One-Touch Pipeline. And this we actually call the primary analysis. And if I now zoom out into the whole software ecosystem, we have additional data types which do not fit into this OTP setting, like methylation data or proteomics data, and we still want to integrate them in what we call the clinical workflow. And this is very specific to our case, right? We have clinical information which flow into a completely different set of software tools. And we want to bring together these two things, the omics data and the clinical data. And this is being done in our decision support tool, which we call the Knowledge Connector, which in addition links all these data to world knowledge. And here's a screenshot of the Knowledge Connector. So it is one among many visualization systems for precision oncology, but there are a few unique features of this product, which is that it actually does not only display variants at the gene level or biomarkers at the single gene level, but it also can incorporate supragenic biomarkers, like, for example, mutational signatures, as it is shown here, or large copy number aberrations, which would involve hundreds of genes, and still you may want to infer information from this. But coming back to the software ecosystem, there also is a functionality for conversion and aggregation of data into a specific format, where we use from R Bioconductor the format multi-assay experiment. So this is a whole pipeline for data integration and aggregation. And then there is some functionality displayed in red here about cohort analysis. So this would be secondary use of data. This is not the primary diagnostic purpose, but the scientific part of cohort analysis and pattern recognition. And so why have I explained all this about the software ecosystem? This is because in our use case, we find that, in fact, we have two in-house IVDs. We have in-house IVD1, which is the primary analysis with the variant calling workflows. And we have in-house IVD2, which is the visualization and decision support system. And these two tools would be examples for what comes later today in the webinar about how to integrate them into a complete laboratory workflow. And Andreas Oberleitner is going to go into the details of this in the later part of the webinar. So after having presented the software ecosystem, I want to briefly mention that we have three different patient streams which go into our laboratory. One is precision oncology programs, which is a research setting, but with patient benefit in a clinical setting. We also have patients who we want to include into interventional clinical trials. And we have actually patients from a non-research setting, from a diagnostic setting. And in Germany, this would in the future be according to a Modellvorhaben, paragraph 64e of Sozialgesetzbuch 5. And of note, all these different patient streams can enter the process chain at different points. And our laboratory setup has to be flexible enough to account for all this. Okay, now I want to come back to the other regulatory context, which is ISO 15189. And in this setting, I just want to mention that the extent and the range of applicability of ISO 15189 is everything from the start of the process chain up to report 1. But it's very important to acknowledge that the molecular tumor board, or also if you would have a rare disease context, for example, the interdisciplinary case conference, would be outside of the range of applicability of ISO 15189. And this is quite important because in these boards, in these interdisciplinary settings, you want to have as much freedom as possible, and you want for the physicians and the specialists in these boards to be able to also recommend, for example, less mature biomarkers, which can still be of benefit for the patient. Or you may sometimes even want to use research-only biomarkers and still base a recommendation for the patient on that. That's why we propose to stop the regulatory setting after what we call report 1. Okay, with this, I'm at the end of what I wanted to show you. And to summarize, we have two different regulatory contexts. One is the IVDR and the other the ISO 15189. In IVDR, I have presented you in the bioinformatics part two different in-house IVDs, but I shall mention that also in the sample preparation and in the next generation sequencing core facility, as they are called in our setting, we also have in-house IVDs, and all together would be the representation of the process chain. And I told you, like, in some detail about these two different in-house IVDs. One is for the primary analysis of all the next generation sequencing data analysis tools, and the other one being visualization and decision support. And about the ISO 15189, I told you that it has a sort of a range of validity for the process chain up to report 1, and that it's quite important that the tumor board or the case conference is outside of the range of validity of ISO 15189. With this, I would like to thank all members of my research groups. It's amazing to work with these people, and none of what I have presented would have been possible without them. I want to thank other colleagues, supervisors, mentors inside and outside of the German Cancer Research Center. I would like to thank funding agencies and you for your attention. Thank you very much.
Thank you, Daniel. It was a very interesting talk. It's always interesting to see on the real cases the complexity of the workflows. Thank you very much. Now I want to show the results of the poll before we move to the next talk. So the first question was, regardless of which tool you're using, what percentage of your lab's in-house tests have you started documenting thus far? And we can see that 29% selected the answer not yet started. 24% have started with less than 10% of their tests. And maybe I will also point out that 11% have already started documenting more than 50% of their tests. And there are, of course, some answers in between. Thank you for your feedback. The second question was, what are the main blockers in making progress with documenting your in-house tests? Multiple choice was available here, and we can see that most of the attendees have selected the answer lacking resources, time, dedicated staff, etc. But it's also nice to see that many users selected the answer where they have no blockers. Thank you. These results will help us to develop our software such that it better meets your needs. And now I want to give over to our next speaker, who will demonstrate what Plato X IVD Assistant software can offer with the regard to complex workflows and compliance of such workflows. Andreas, please.
Thank you very much. Thank you, Elena, for the introduction. And also, of course, a big thank you to Daniel for the demonstration of the real case workflow. We have seen already how complex such a workflow could become and how important it is already in the beginning to think from the strategical point of view to identify in-house devices within such a complex workflow. I think what is also very interesting information here is that 15189 and IVDR, we have two things to consider here. They are somehow overlapping, but they are not definitely not the same. So a 15.1.9 is a good start as a basic for the quality management system aspects. But still, with the IVDR, we have still more things to consider, still more things to do to cover the requirements from the in vitro diagnostics regulation on in-house devices. Before I would like to start with the demonstration, I would first give you some more information with some slides. For that purpose, I would like to share the screen. I would like to get back on the point of view where we now stand with our program, with the IVD Ready program, and what it would mean with regards to our actual product with the PlatoX IVD Assistant software as a service platform. What we already have in place is the first part, which means the documentation strategy, especially when the workflow contains a lot of different devices, CE marked, non-CE marked RUO devices, devices which are using inside the or outside of the intended purpose. It really makes sense to first think of a good strategy, how to maybe combine, or if you need to segregate some parts of the workflow, as we also have seen in the example before, where the workflow definitely is going to be segregated into different steps. Those things are really important before you even start on considering starting your documentation, because if you have many workflows, you probably have a good chance to combine some of the aspects based on their similarity, for example. For that, I would one more time encourage you to have a look onto our website. We have a clickable tool with completely free access on it, which you could use and which could help you in identifying some of the potential strategies based on your individual setting. After that, we already introduced a tool regarding the creation and formulation of intended purpose statements. This is particularly important because the intended purpose statement is more or less the center of everything from the regulatory point of view. And from the IVDR standpoint, there's a lot of requirements which you need to consider to formulate that. We already integrated that already in our platform. The same is true for additional things like the qualification as an IVD. You should also be able to demonstrate that your diagnostic workflow or in-house device is qualified according to the IVDR as an IVD, and therefore the IVDR is applicable at all. And last but not least, we already talked in the past about risk classification according to the Annex 8 of the in vitro diagnostics regulation, which divides the devices into 4 risk classes from A to D. There is no explicit requirement that you need to do it for in-house devices, but for sure there is an implicit requirement because you need to know about the class of your device. Otherwise, you cannot identify which requirements at the end really need to be applied on your device. So therefore, this is also already integrated. And that's what we have seen already in the past. You can do all of these things in the PlatoX IVD Assistant platform already right now. With today, we are very happy to announce that we made a huge leap forward by developing and also publishing the Workflow Studio. This is an extra module which is part of our platform, and with that you can specify your workflows, you can define and describe the steps, and you can assign components and products to each of those steps for the relevant workflow you want to document. Why this is such an important or relevant thing, we will see in a minute. Of course, this is not yet the end. More things have to follow. You can see our roadmap in the IVD Ready program that has been presented already by Elena. Good, and with that, I would like to switch over to the product demonstration. And for that purpose, I would directly jump into our application. Just a disclaimer, what you see here, of course, is a demo environment, an internal one, because for legal reasons, we are not allowed to demonstrate real use cases from real customers, of course, but I think it gives a very good idea already how it would look like. So just note that all of these devices here, all of these workflows, and also every product which you will see later on is of course just a demo product and not a real product. We always start with the list of devices. I'm now logged in as a laboratory user, and on this list I can see already which workflows I have defined and documented so far in this environment. Each of these documentations, each of these lines here in this table represents a project or an in-house device at the end which you want to document according to the IVDR requirements. For the sake of time, we already prepared a demo workflow here, an NGS demo workflow. And as you have seen before with the picture with the arrows, we follow a certain workflow from top to down. And this workflow should also help you in following the right requirements one after the other. So it gives a certain guidance also to the users. Typically, you start entering general information. We had that already. And for the intended purpose, we have implemented a wizard that helps you by asking you several simple questions. And all of this information will be processed and afterwards used to enable you to pre-populate the relevant documents, which you would later use to demonstrate compliance with the IVDR. So the pattern is always similar. First, so we turn it around. First, we are asking you questions regarding your device, and based on your entries, your given information, this information will be processed within the system. And so we move from a document-centric approach to a data-centric approach, which of course has a lot of advantages concerning the reliability of this data and also consistency and so on. With risk classification, we had already the same. And what is new right now is the Workflow Studio. And if I click now on the Workflow Studio, you can already see how it looks like. So what you typically can do here is define how your workflow looks like. This is necessary in such use cases where you want to combine several devices, including maybe own developed devices or REOs which have been repurposed and so on, into a kind of a system. We're using the system term here. So therefore, it makes it easier to set up your own workflow as kind of a system, and you just define it as you're used to it. So that means that you probably have a couple of steps, like here, DNA extraction with a certain description, a quality control step, a library preparation, a quality step on that again, and sequencing and so on. This is the first thing. The second thing is that you can now assign components to each of these steps. So these components then would be the devices which you're using within each of these steps. So for example, in the DNA extraction, there's obviously this kit here used to fulfill the tasks within this step. Why is this important? Because the components here, they are attached with a lot of regulatory information in the backend, in the background. And by assigning a certain component here on this step, it means that the system now knows that this component is used in the relevant step and therefore can process all the information given and provided already by the manufacturer of this component and can pre-populate this information exactly into your own documentation. And that really saves a lot of time because the manufacturer already provides this information and you do not need to look up for this information in instructions for use or in safety data sheets or asking the supplier themselves. So that means that this information is already available via the platform and can be used automatically. If you, for example, then decide to add more components, just demonstrate quickly how this looks like. So for example, for this step number 5, sequencing, it tells you a step is incomplete because there are no components assigned yet. I select a component, then I get a long list here. I just have to move this here over. I get a long list of the components, and as I said already, those are of course only demonstrational components here in that case, but I think the idea is clear. And for example, I can then look up for components which could be suitable. There will also be a filtering and search functionality available very soon. But for example, if you allow me to search for a sequencer, because I'm now in the sequences step, then I find one component here, and I could use it and add it. If I'm not yet happy with the component here, because it's not yet available and I have another component in mind, I can do so as well. And this is really another very important point where you can help us to help you by requesting a certain component which is not yet available in the platform. I can easily enter a component name. For example, I'm looking for a certain sequencer again from a certain manufacturer, which is maybe one of these two. So you can see in the dropdown every manufacturer that has already been entered. Of course, please keep in mind this is only the demo instance here, so therefore those are not real manufacturers. And I can then say, okay, I would like to see the product of company X. And probably I also have a catalog number at hand to identify the product because I already know it. For example, 1, 2, 3, 4 in that case. And by clicking on request component, this component will now be requested directly to the manufacturer if they are already on the platform, or handled via Platomics if they are not yet on the platform. But let's say we will take this component here for the step. Then scrolling down again, you can see that now this component has been added. And of course, this looks very simple on the front end. Yeah, it's the component which has been added. But in the back end, under the hood, so to say, a lot of things happens with that step. It means that all the information that is available in the platform for this certain genetic sequencer here is now also made available to the documentation, and the documentation can make use of it. So that means if we go back now and have a look into the next document, which is a documentation dealing with the workflow specification, then you will see that first this template is already preset because the template is already pre-built within the tool. So you do not need to start from the scratch. You have already the whole structure made available. But not only that, because we are working with variables and all the variables which are available for this document and already pre-filled are already populated in the relevant positions. Maybe you can see it with the gray background here. Everything here, those are variables, and they are reused in all the documents in the same manner. So there is no danger of having inconsistencies anywhere. And regarding the workflow description, you see already that there has been one overview chapter, which one more time exactly explains the steps you have defined in the studio, of course, but there is also a second section that explains exactly which components are used in which step. So this document is maybe already ready for finalization and review and release. Yes, so this is exactly how the information from the manufacturers, your information, which you are populating into the tool, and also the aspects which come together with the templates and are already provided by the platform itself. And these 3 steps together allow you a really fast creation and also making ready of the documents in future. Of course, this is a quite simple example here with the description of the individual components in the steps of your workflow. But with the next releases, we will have then, according to our IVD Ready program, where we are dealing then with aspects like general safety and performance requirements or performance in general. You will see that a lot of this information then will already be made available. And this will, again, really save a lot of time and really pays off afterwards, as soon as this next wave will be released. So I would like to get back one more time to the slide deck to give a few words on the concept one more time. So as you have learned, we have wizards helping you in collecting the information and data. This data is collected in a data model in our platform, and together with the templates and also certain regulatory rules, you will be helped a lot to create your documents, which have been pre-filled and already are available. And of course, you can edit all of these documents within the system to your needs. But there is one more aspect right now. We know that sometimes we need more information within the system. And in one of the past webinars, we already presented the knowledge base, helping you in learning about certain regulatory terms, for example, getting more information on resources. We have a built-in glossary and so on. So this already facilitated a lot. But now with the new topic we are discussing today, we have a new information stream, which means that manufacturers providing information on their products, registering the products on our platform, and the component data is now processable throughout the whole system. And this information can be directly used in your documentation. So that means the 4 columns or 4 pillars of our ancient Greek temple means that so this is our philosophy. We want to provide guidance throughout the tool, through the process, giving you the red thread through the whole topic. We want to provide you with the right framework, which is according to the IVDR, and providing you with the relevant templates and the whole outlines. We also want to help you in creating the content by a lot of automation. A lot of things can be automated and also be reused through the system in the digital way. And the new aspect here, of course, is the components information topic. Last but not least, we want to provide you with sufficient knowledge in to be able to answer the last questions as well. So I think this is maybe the message we also want to give you. We are thinking in data, not in documents. This might be relevant because thinking in data really allows us to make all of this information readable and reusable. And with this, we think we have a really good way in ensuring plausibility, completeness, consistency, allowing the automation, and last but not least, also guaranteeing a certain quality of the content. Yeah, with that, I'm at the end of my presentation, and I would like to say thank you and hand over back to Elena.
Thank you, Andreas. I want to share just one last slide with you and stress out that Workflow Studio that Andreas presented right now will be available on Laboratories portal on October 19, so next week. And starting from this day, we encourage all laboratories to design their workflows. And since we saw in our poll that many laboratories are not working in parallel on different in-house LDT in-house test documentation, we encourage you to actually start doing this in parallel and document as many workflow designs as possible already now, and add components to those workflows, and if necessary, request these components, as Andreas already said, help us to help you and help manufacturers as well to prioritize registration of the products. Because as you know, many manufacturers have a very large and versatile product portfolio. So it would help us all to know which products have to be registered at first, for which products there is the highest need at the moment. We are through our agenda today. I want to thank again our invited speakers, Daniel Hübschmann and Andreas Oberleitner, for their presentations, for very interesting information they shared with us today. We are finishing a little bit earlier today since we are already reaching the middle of IVD Ready program, and we are trying to optimize the content and the duration of our webinars for you. And we also prepared a very short survey consisting of 5 questions where we ask you to provide your feedback about IVD Ready program in general and about this webinar. You will see it appearing on your screens. With this, I want to thank you once again. I want to wish you a nice rest of the day. Stay in touch and get IVD ready with Platomics. Thank you.